Hello class, welcome to Pre-Algebra Lesson 3.8, which is all about multiplying and dividing mixed numbers. By the end of this lesson, you should be able to apply an understanding of multiplication and division to rational numbers and use the order of operations to solve real-world problems. So this is our second day on this lesson. Yesterday we practiced just multiplying and dividing improper fractions. Today we are adding one more step of mixed numbers. So we are going to practice converting the mixed numbers to the improper fractions, and then it's just like yesterday. So if we look at example 1, we are multiplying 1 1/5 times 2 1/3. So 1 1/5, let's remember how we convert to an improper fraction. You take your denominator, so the bottom of the fraction, multiply it with the whole number, so 5 times 1, and you add the numerator, so plus 1. 5 times 1 is 5, plus 1 is 6. So 1 1/5 equals 6/5 as an improper fraction, times, and then our second fraction is 2 1/3. So again, we take the denominator, that bottom number in the fraction, and we multiply it with the whole number. So 3 times 2 is 6, and then you add your numerator, which is 1. So 6 plus 1 is 7 over 3. And now it looks like just what we did yesterday. Okay, so what I could do now that I have my two improper fractions is I can just multiply across. So 6 times 7 is 42, and 5 times 3 is 15. And then I want to reduce that as much as I can. So I know 15 can go into 42 2 times without going over, and then I would have 12 left over. So then I have 2 12/15. Now something to pay attention to is my fraction. Look at that. I have 12 over 15. That can still be reduced. What number goes into both 12 and 15? The number 3. So if we do 12 divided by 3, we're left with 4 on the top, and 15 divided by 3 leaves us with 5 on the bottom. So our answer would be 2 4/5. The other option is to simplify before multiplying. So this is the other thing I showed you yesterday. You reduce on the diagonals. So if I look, 5 and 7 can't be reduced, but the 3 and 6 can. So the 6 would become a 2, the 3 would become a 1. 2 times 7 is 14. 5 times 1 is 5. And then 5 can go into 14 2 times without going over. And then there would be 4 left. So you can see I would have 2 4/5. So it doesn't matter which option you choose, your final answer ends up being the same. So like I said yesterday, pick the one that you feel the most confident with and stick with it. Okay, you don't have to do both methods. Pick the one that works for you. All right, let's try another one. We have 5 4/5 times 1 2/5. Let's convert to our improper fractions. So the denominator times the whole number. 5 times 5 is 25. Add that numerator. 25 plus 4 is 29 over 5 times. Now let's change our second number into an improper fraction. 5 times 1 is 5 plus 2 is 7/5. Now if I use a calculator, because no, I don't expect you to know what 29 times 7 is off the top of your head, you will end up with the number 203. So 203 over 5 times 5 is 25. Then we want to reduce that. So how many times can 25 go into 200 without, or 203 without going over? It can go in 8 times, because 8 times 25 is 200, which means that there are 3 left over, and then our denominator stays the same. So 8 3/25. All right, so I've done 2 examples. It's now your turn to try doing one on your own. Good luck. Okay, so if you converted everything to our improper fractions, you would end up with 29/6 times 11/7. 29 times 11 is 319. 6 times 7 is 42. 42 can go into 319 7 times without going over. And then when you look for the remainder, you are left with 25. So 7 25 over 42 is your answer. If you have questions about that, please be sure to ask for some help. I'm happy to help you. All right, let's move on to dividing fractions now. So we have 3 1/2 divided by 1 1/6. So again, I'm going to change these to my improper fractions. So 3 times 2 is 6 plus 1 is 7 halves divided by 6 times 1 is 6 plus 1 is 7 sixths. Remember, dividing fractions you keep, you change from division to multiplication, and you flip your second fraction. So I'm sorry if the keep, change, flip song is now stuck in your head, but it is helpful. So you can either multiply across or you can reduce first and then multiply, your choice. So if I do 7 times 6, I get 42 over 2 times 7 is 14. 42 divided by 14 ends up being a nice whole number. That is 3. Okay. Then let's move on to the next one. We have 7/10. That's already done. That is not a mixed number, but we're going to convert the 1 1/6 to 7 sixths. And I accidentally wrote multiplication, but that is still division. All right, so 7/10 divided by 7 sixths. We keep our first fraction, 7/10, change the division to multiplication, and we flip our second number. So now if we multiply, we get 7 times 6 is 42 over 10 times 7 is 70. And some of you are often asking, like, okay, I know that this number can reduce, but how do I tell? So remember, if both of the numbers end or if both numbers are even, they're at least divisible by 2. So that's always a good thing to check. And then you can always check if it's divisible by 2. You can look, does 4 go into it, 6, 8? Check your nice even numbers. So if we just did 2 here, that would be 21 over 35. And then looking from there, 21 and 35, I know, are both divisible by the number 7. So 21 divided by 7 is 3. 35 divided by 7 is 5. So our answer is 3/5. All right, last division example. I have 10 divided by 2 1/4. So some of you might be wondering, okay, I don't have a fraction with that first number. So what you can do, anytime you have just a whole number, no fraction, you can turn the whole number into a fraction by putting it over 1. So it's going to become 10 over 1 divided by 2 1/4. I do 4 times 2 is 8 plus 1 is 9/4. And then I'm going to keep my first fraction, change to multiplication, and flip my second fraction. So now I have 10 times 4 is 40. 1 times 9 is 9. 9 goes into 40 4 times with 4 left over. So my answer is 4 4/9. Okay. Last question for you to do on your own. 2 4/7 divided by 3/4. Good luck. Okay, so now you can see that I arrived at the answer 3 3/7. Feel free to look through my work and compare to see if you have anything different. If you have any questions on how I got that answer or anything else from this video, please reach out for help. I'm happy to help you. I hope you guys have a great day.